So we've explored. That's me in the brown, talking to some members of our department a number of years ago when we obtained a green seeker sensor, and this is one of a couple optical sensors that's on the market right now. Tech has the green seeker marketed by Trimble, and then there's another sensor that we have yet to use in beets, but we plan to next year, called the Holland Scientific crop circle sensor. Both of them work on the same kind of principle, although the wavelengths they work with are a little bit different. But this particular one uses a ratio of NdVi. It's an active sensor, so it throws out its own light and reads its own light. You can get the same reading at noon as you can at midnight. So clouds, variations in color really don't bother it too very much. So we wanted to use it a little bit for beets and see if we could make some improvements. Because there are some advantages of using the ground-based sensors. Sometimes with satellites, when the satellites come over at the time you really want one taken, there are clouds in the way, and so it disturbs your view. And the shadows on the field also could make a difference. Depending on what image you get, the satellite pixels could be very wide apart, and so some fine detail that might be important may not show up, and it's all averaged together. So the ground-based sensors, the scale of the readings are much finer. You get it in square feet instead of lots and lots of square feet. And then one of the things we looked at is to take a three-dimensional picture of the field. Since we were using it as a cover crop, we wanted to see if a three-dimensional picture instead of just a two-dimensional picture gave us a better idea of what the biomass was and what the nitrogen was at the end of the season. So we did that. We went out to a field north of here, about 70 miles near Crookston, Minnesota, in a beet field, and ran the green seeker across the canopy. We had an experiment at that year and some fairly densely gridded areas within the field, and we compared the NdVi alone, which is the green seeker reading, to the green seeker reading times the canopy in inches, I believe. And the correlation we got between our reading and the dry matter and an N content, which is a concentration, and the total N on the tops, wasn't too bad. An R of 0.4 to 0.51 wasn't too bad, but when we multiply times the canopy, then our estimate became quite a bit better. Dry matter content, nitrogen content, total N. So there are some people using this technique in the valley. A farmer in the area, fairly progressive, mounted one on his defoliator, that mower I showed you, the first slide. And so he was taking a picture right at the time where he's actually mowing the beets. And so this is a comparison of one of the fields. The image you see on the left is with the satellite taken about a month before harvest, and the one on the right is with the ground-based sensor. The detail on the ground-based sensor is certainly finer, and the day of harvest, I think, could be important too. There were some things that the satellite showed that the ground-based sensor also showed. This difference in variety up here in the north is the same in both of them, but this fine detail in the southeast is not really shown on the satellite. So depending on how important that is, that fine detail could be important.
David, just to start with a question, and also I encourage if any questions come up, please send them through the chat window, and we'll be doing some breaks to go through them in order. No, my only question is, what satellite system were you using in this case?
This was a Landsat 5 also.
Thank you. Yes, because we'll be working with sample data in each of the participants' fields, which will be Landsat data, and we'll also be knowing a bit more about other commercial systems available towards the end of the course.
Okay, good.